Hello everyone, welcome back to chapter number 11 of our Azure series. So in this chapter we are going to explore another important service under Azure networking, and that is load balancing. But before we jump into the details of how load balancing works and why it is crucial for scalable application, let's do a quick recap of chapter number 10. So in the last chapter, we performed a hands-on demo where we created a virtual network VNet in Azure. Then we set up a virtual machine inside that VNet and deploy a React application on that virtual machine and added a DNAT rules using Azure Firewall. And finally learn how to securely access the hosted app using VNet configuration and firewall rules. So if you missed that or any of the previous chapter related to the Azure networking, I highly recommend you to check them out first. It will give you the foundational knowledge to understand how load balancing fits into the bigger picture of app performance and availability. So now let's move forward and dive into the load balancing in Azure, what it is, how it works, and where it fits in the real world cloud application. So let's get started. So now let's try to understand what exactly load balancing is. In simple terms, load balancing is the process of distributing incoming network traffic across multiple backend servers to make sure no single server become overwhelmed. This helps to maintain performance, availability, and reliability of your application or servers. Now let's try to understand this terminology with very simple example. So think of a restaurant with multiple service counters. When customer arrives, the receptionist directs them to the counter with the shortest queue. This helps to serve customer faster and ensure that no single counter is overloaded. That's exactly how load balancing works in the world of networking. So now let's try to understand how does load balancer work in Azure. So as you can see on the screen referring to this diagram here, how the flow works. User make a request from the internet which comes through the public IP address. That request first hits the Azure load balancer, and the load balancer then forward the request to one of the servers in backend pool, which typically contains virtual machines. These virtual machines are grouped together inside a subnet and are managed using the virtual machine scale set VMs, which is nothing but a group of virtual machines. Then the load balancer smartly distributes the traffic based on the current load availability and defined load balancing rule. If the number of incoming requests increases, the scale set automatically creates new virtual machine instance and distribute the traffic accordingly and scaling up. If the traffic reduces, the scale set can be scaling, removing unnecessary virtual machines to optimize the cost and resources. So in this way, this load balancing work behind the scenes in Azure. So here are the key components of load balancer. That is number one, front-end IP configuration. This is the public or private IP address that user connects to. It acts as an entry point to the load balancer. Then second, that is backend pool, a group of virtual machines or instance that will handle the actual processing of requests. Then number three, load balancing rules. These define how traffic should be distributed among the backend servers. And then inbound NAT rules used to map specific ports of front-end IP and a particular virtual machine instance, typically for scenarios like remote desktop or SSH access. So in summary, the Azure Load Balancer ensures that the incoming traffic is smartly distributed across multiple virtual machines while also handling automatic scaling, health check, and high availability, all behind a single static IP. This forms the backbone of building scalable cloud application. So now let's take this one step further and talk about the load balancer works in real world multi-tier application setup. When we build multi-tier application, for example, application with separate web layer, business logic layer, and data layer, we typically use dedicated load balancer for each layer. For instance, as you can see on the screen, the web layer handles the incoming request. A front-end load balancer manages traffic across multiple web servers. The business layer has its own internal load balancer that distributes the request to the backend servers or APIs. And data layer might also have a load balancer to manage queries across database, replicas, or services. This separation ensures efficient traffic distribution at every layer, scalability since each layer can scale independently based on the demand, and security as traffic between layer can be filtered and controlled tightly. So in summary, load balancer not only manage traffic across identical servers but also across the different functional layer of complex application, ensuring smooth, secure and high performance operations. So far in this chapter we understood what load balancing is, how it works with backend virtual machines and scale sets. Key components like front-end IPs, backend pools, rules, and NAT rules, and how it applied in multi-tier application. So now it's time to move into the hands-on demo. In that we will create two virtual machines, set up Azure Load Balancer, and then we'll see how requests come through the public IP of Load Balancer are intelligently routed either to the virtual machine 1 or virtual machine 2 based on the configured rule. So let's jump to the Azure portal and let's and start setting up the load balancer step by step. So once you log into the Azure portal, then we will be navigating to this landing page or the dashboard of this Azure portal where you can create the virtual machines. So as I mentioned, we'll create two virtual machines, and in that we'll simply create a static HTML page where we will add the tag h1 tag with some headings, and then we'll create the load balancer and we'll add some rules to that load balancer, and then we'll try to access with the public IP address of the load balancer, and we'll see how the traffic will be distributed to these created virtual machines. So now let's quickly go to create the virtual machine. So let's do the global search virtual machines and let's click on the virtual machines, and here you will have two options. Either you can click on this plus icon and create drop down, or you can simply click on this create button. So let's click on this and choose the option that is virtual machine, and once you click, then you will be navigating to this new window where here a couple of tabs are present like basic, disk, networking, management, monitoring, advanced tag, and review plus create. And accordingly on the right corner the estimated monthly cost will be auto calculated as per the selection of the size of virtual machine and the region of that virtual machine and everything. And so I am using this pay-as-you-go subscription. So now let's quickly go and fill the basic details. So in the basic details, the subscription that is auto populated, and the resource group that is currently it's not created any resource group. So now let's click on create new resource group and give the name that is load balancer underscore demo, and then click on OK. Then it is mapped. So now let's give the virtual machine name. So we'll keep the simple name that is VM1 for the virtual machine name, and we'll use the location that is Central India. But in your case, you can, if you want, you can change the region as per the requirement and the location. And the availability zone will keep the most of setting as is. So this zone will not select anything. So we'll use this no infrastructure redundancy required, and the security type that is trusted launch virtual machine, and the image I'll use this Ubuntu server 24.04. But if you want to change, you can simply click on this see all images, and then you will be navigating to the marketplace where you can choose the image and accordingly it will be selected. So in our case I selected this Ubuntu server 24.04 latest, and the size of the virtual machine. So I'm doing this for the demo purpose. So I'll keep the default one, that is P1S, that approximately cost like 0.93 cost per hour. So I'll use this one, and then so rather than I'll use this one. But if you can see there are a couple of series, so as per your requirement you can select those. So I have selected like this, and then on the authentication type we'll use this password. So I'll give the name that is TA1, and we'll give the password that is and confirm password, and this selected inbound port so will allow SSH and HTTP. So now let's quickly go to the disk. So we don't need to change anything on the disk tab. So let's jump to the networking, And here you can see the virtual network is auto-populated, it is automatically created, and the subnet and public IP which is not created yet, so subnet, and then the selected inbound is 80 and 2020, and let's select this checkbox delete public IP and NIC when virtual machine is deleted. So once we trying to deleting the virtual machine, so its associated public IP will be automatically deleted. So let's again, we don't need to fill on the management or monitoring, so let's quickly click on this review plus create, and it will validating the details that we entered. So if you can see running final validation, and if everything goes well, then all the details will be presented, so resource group, the location and everything. So let's click on create, and it will start the initialization and the deployment will start. If you can see on the right corner that is submitting deployment is in progress. So once the deployment is done, then we again go back to the dashboard and we'll create virtual machine 2. Virtual machine 1 is created. Now let's quickly go to the go to resource, and then it will be navigating to the overview page of the virtual machine. Here you will see all the details, the resource group that we created, the public IP address and all the details. So now again go back to the dashboard and create virtual machine 2. So let's follow the same steps that we done for the while creating the virtual machine 1. So I'll select the resource group, that is load balancer demo, and we'll add the virtual machine name, that is VM2. Select this one, and the size we'll use yes. Again use the authentication type, that is password, and I give this DA2 and enter the password and confirm password, and just select the inbound ports and simply click on disk. You don't need to fill anything on the disk tab. So now let's go to the networking, and you can see on the networking tab this VM2 VNet is created, and the subnet and the default public IP is also associated with that. So let's enable this checkbox and simply click on review plus create, and once everything is okay, then let's click on create. So it is submitting the deployment, and now deployment is in progress. Once that is done, then we'll done with the step 1, that is creation of virtual machine. So now deployment is completed, and let's go again back to the overview page of virtual machine 2. Here you can see all the details that we added. So now I have created a simple HTML page on the virtual machine 1 and virtual machine 2. So let's try to see how it look like. So I'm in virtual machine 1, so let's copy the public IP of virtual machine 1 and try to enter at the port number, that is 80, and then you can see connected to VM is there, and then again go back to the virtual machine 2 and then copy the public IP of VM2, and then you can see we are connected to virtual machine 2. So let's close the browser and go again back to the dashboard or the home page of the Azure portal and try to create the load balancer. So now let's quickly create the load balancer. So once we click on the load balancer, then we'll be navigating to this page. So now let's click on the load balancer and select the standard load balancer, and we'll be navigating to this window. There are a couple of tabs, that is front-end IP configuration, backend pools, inbound rules and outbound rules, that we have already seen on the introductory part or the theoretical part of this chapter, where we see these load balancing key components. So now let's quickly fill the basic details. The resource group, let's select the resource group, then give the name. We'll give the name, that is TA load balancer LB demo, and then region, that is Central India, SKU, that is standard, type it's public, and the region, that is regional. So that's it. Then let's click on the front-end IP configuration, and here let's click on this add front-end IP configuration, and in that we'll give front-end IP, we'll give the name, then the IP version, that is IPv4, IP type, that is IP address, and then let's select the public IP address. So let's create one new public IP, that FIP, and then will not use any zone. So let's save. Okay, and then that is populated. Let's save this one. And you can see this fronted IP configuration is added. So now let's go to the backend pools. Here, let's click on and add backend pool and then give the name. So backend P, and then select the virtual network, that is VM1, and in that we'll select the IP address, and in that let's on the IP address list there are two IP addresses, that is 10.0.0.4 and 10.0.0.5. Those are the private IP address of our created virtual machines. So again, let's go to the dashboard and let's go to the virtual machine 1, and in that go to the network settings, and here is the private IP address of our virtual machine 1, that is 10.0.0.4, and likewise for the virtual machine 2 network settings, and the same, that is 10.0.0.5. So let's select this one, then this one, and then let's save. Once that is done, then you will see all these two private IP will be mapped to in the backend pool. So now let's go to the next tab, that is inbound rule, and in that let's click on this add load balancing rule, and in that we have to set up this front-end IP address and backend pool addresses with this load balancing rule. So we'll give the name, that is load balancing rules, and then the IP version, that is IPv4, and then front-end IP address that we just created, and then backend pool that we have just created, that is backend. Then let's scroll down, and the port, so our front app is running, or the HTML page is running on this 80 port, and the backend pool also running on this same port, that is 8080. But if the backend is running on the different port, then we can change the port number as per the requirement. So then on the health probe, so currently it is not exist, so let's click on create new, and then we'll give the default one, default, then the protocol, that is TCP, port number is this, and interval time is 5. Let's save this, and on the remaining part we don't need to change anything, so let's simply click on save, and then go to the next tab, that is outbound rule. So currently we don't need to set up the outbound rules, so simply go to the review plus create tab, and once this validation is done, validation is passed, and then simply click on the create load balancer. So it is starting this deployment. So now the load balancer deployment is completed. So let's quickly go to the resource, and this is the overview page of our created load balancer, and in that we can see the resource group, subscription, and the backend pool IP, and the health prop that we just created, and this load balancing rules that already mapped. So now let's try to check the how the load balancing will work. So for that, let's expand the setting and go to this front-end IP configuration, and in that let's copy the IP address, and then open the new browser and just paste, and let's click on enter, and you can see we are navigating to this virtual machine 2. Then again I will try to run this one more time. We are again connected to or navigating to this virtual machine 2. So let's do in incognito mode, and then let's try this one, continue site, and you can see now we are connected or navigating this, our request will be navigating to this virtual machine 1. And that's all about Azure Load Balancer. So in this chapter, we learn how to create and configure load balancer in Azure to efficiently handle and distribute incoming traffic across multiple backend servers. So let's do a quick recap what we covered in this chapter so far. We started by understanding what is load balancer and how it works behind the scenes. Then we explored the key components such as front-end IP, backend pool, load balancing rules, and inbound NAT rules. After that, we discussed how load balancer are used in multi-tier application, managing traffic across different layers like web, business, and data. And finally, we wrapped up with a hands-on demo where we created two virtual machines and connected them with a load balancer and see how traffic is distributed in real time. So if you found this video very helpful, then don't forget to like, share, and subscribe to support the channel. And as I always say, keep learning, happy coding, and I'll see you in the next chapter. Until then, have a great day.